Welcome to Knowledge Hub. Today we're exploring a fascinating cosmic phenomenon. What happens when stars kiss? When we talk about stars kissing, we're referring to the dramatic and often catastrophic interactions between them. Unlike the gentle imagery the term might evoke, these encounters are anything but tender. Instead, they involve intense gravitational interactions that can lead to spectacular and violent outcomes. Types of stellar interactions. In binary star systems, two stars orbit a common center of mass. Depending on their distance and mass, these stars can exchange material through gravitational forces. If the stars are close enough, one can start pulling matter from its companion, leading to significant changes in both stars. Stellar mergers. Occasionally, stars come so close that they merge. This merger can result in a single, more massive star, or it can trigger a cataclysmic event like a supernova. When two massive stars merge, the energy released is immense, often outshining entire galaxies for brief periods. The physics behind the kiss. Gravitational waves. The collision or close encounter of stars generates ripples in spacetime known as gravitational waves. These waves travel across the universe and can be detected by instruments like LIGO and Virgo, providing valuable insights into these distant events. In some cases, the interaction between stars can lead to a supernova or a nova. A supernova is a colossal explosion that occurs at the end of a star's life cycle, while a nova is a smaller but still dramatic explosion caused by the accretion of material onto a white dwarf in a binary system. Observing stellar kisses. Astronomers use various telescopes and instruments to observe these stellar interactions. Space telescopes like Hubble and ground-based observatories like the Very Large Telescope, or VLT, capture detailed images and spectra of these events. Case studies. One notable example is the binary star system V838 Monocerotis, which underwent a dramatic outburst in 2002. This event was observed across multiple wavelengths, providing a wealth of data about the processes involved in such interactions. The aftermath. Formation of new stars and planetary systems. The material ejected during these interactions can contribute to the formation of new stars and planetary systems. The remnants of a supernova, for instance, enrich the surrounding space with heavy elements necessary for the creation of new celestial bodies. Black holes and neutron stars. In more extreme cases, the end result of a stellar kiss might be the formation of a black hole or a neutron star, depending on the mass of the original stars involved. These remnants are among the most exotic objects in the universe, with unique properties and behaviors. Conclusion. The universe is full of dynamic and powerful events, and the interactions between stars are among the most spectacular. From gravitational waves to supernovae, these cosmic kisses reveal the incredible forces at play in the cosmos. By studying these events, astronomers can better understand the life cycles of stars and the evolution of galaxies. Thank you for joining us on this journey through the cosmos. If you enjoyed this video, please like, subscribe, and hit the notification bell for more fascinating explorations of the universe. Keep learning and stay curious.